Okay, so this example, I want you to have a look at the question first. Just read through the question. Give yourself a little bit of time to mull over what it's asking you. And what's the problem with this is that if we're trying to find the inverse of A, if you got the actual starting point, we don't have the inverse of A in that equation. So the first trick here would be to somehow introduce the inverse of A into our equation. The simplest way of doing that would be to pre-multiply all of the terms by A minus 1. So we end up with the inverse of A times A squared equals A inverse 2A plus A inverse 3I. Let's split all this up and see what we can do. This is inverse A, so A squared is A times A, equals, now we have the number 2. The number 2 in this little term here can go anywhere where we want it, affect the outcome at all. So we can write that. Similarly with the 3, we can have that term there. Now, what we're doing here is we're going to combine A minus 1 with A, which gives us I, the identity matrix times A. Similarly, we're doing the same thing here, which will give us 2I, and then add on. Now, the identity times anything just leaves it the same. So this would be the result of that. So what we've got, we have simplified those combinations of A and A inverse, and with the I and the A inverse as well. So what we've ended up with is that the identity times A is A will equal 2 plus 3 lots of that. Let's just rearrange things around now. Missed out the identity there, so that's A minus 2I is 3 lots of the inverse. So we're going to have A minus 2I all divided by 3 is the inverse of A. Now let's have a look at what we've got. We've got to find R and S. We can't go any further with it, but we can say this. Let's just write this in a slightly different form, which is 1/3 of A minus 2/3 of I, just by splitting that fraction up. Okay, this implies then that R, the scalar R, is 1/3 and S is negative 2/3.